Hey everybody, welcome back to CSE 1322. In this lecture, we're going to talk about exceptions and exception handling. So first off, what is an exception? Well, basically, as you're writing code, you need to start getting in the habit of thinking through what edge conditions can happen or what problems can happen when the user is running your code. Honestly, this is a big part of being a developer, is thinking through what the user could do and what circumstances that they might end up in that you've never thought about. So exception handling is starting to write code to deal with those circumstances. And so we're going to take a look at a few new keywords, which include try, catch, and finally. And we're going to also show you how to write your own exceptions and how to deal with them. Okay, so exception handling is for dealing with stuff that could happen that isn't always going to happen. So before we had exception handling, we basically had to check every single method that we called and every function and see its return value, which was not a very great way of doing things. So let's take a look at a block of code and see what could possibly go wrong in this code. So here we have just a starting off in main, we have a couple of variables declared int1 or num1, num2, num3. We have a scanner declared, and then we ask the user to enter in number one. We read that in. We ask the user to enter in number two. We read that in, and we give them a result, which is number one divided by number two, which we print out. So the first thing I can tell you is that there are no syntax errors on this slide, or if they are unintentional. This is all perfectly valid code that you can type in and it will run. And if I type in 10 as my first number and I type in 2 as my second number, it will successfully return 5. It logically produces the correct output. So there's nothing wrong with the code per se, but there is a circumstance that the user can give me a value that can cause this to crash. So I want you to think about that for just a minute and come up with what you think that value is. And again, much like we were talking about with recursion, where you're tending to look for the extremes, it's probably going to be an extreme here as well. You're going to want to think through, well, what circumstance could they give me that's going to cause a problem? So the answer is, well, what happens if they give you a 0 for num2? Then all of a sudden you have num1 divided by 0, and you know that it's not valid to divide by 0. Since all of these are stored as integers, this code will actually crash if you do that. If I were to paste this into IntelliJ, type in 10 and 0, I will get a divide by 0 error. Now, interestingly, depending on the type of the variable that you're storing, divide by 0 is sometimes allowed by Java and will return infinity. That's true if you start off with floats or doubles instead of integers. But this is going to produce a divide by 0 error. All right, so let's take a look at another circumstance. So here we have another block of code. We declare an array which has, it looks like, 50 integers in it. All right, and so that's all good. Then we create a scanner. We ask the user to enter in an element number. We read in the element number, and then we print out what is in the array at that element number. So we're taking the user's input and we're using that to find an element in the array. So what could possibly go wrong here? Well, I think you've probably figured it out that the issue here is what happens if user input is a number that's outside of the size of the array. For example, if the user gives me -1, or if the user were to give me 51 or 60, or even the number 50, because it's 0 to 49 that are valid, that will produce a crash. So let's take a look in IntelliJ and see how these crashes actually happen. Like, I need to show you what crashing code looks like. I'm sure you've run into it many times before. So we're going to start a new project here, and this is 5.1. Okay, so what I'm going to do is I'm just going to shortcut the previous example. I'm going to say int1 equals 10. Sorry, num1 is 10, and then int num2 is 0, and then I'm going to say int answer equals num1 divided by num2. And we're going to go ahead and print out the answer. All right, we're going to run this code, and poof, what we see is, there we go, exception in thread main, Java lang, arithmetic exception, divide by 0. Okay, so there's a couple of things that I need you to be aware of. When you are reading error messages from Java, it tells you a whole bunch of information in here. So it's telling me that the actual problem is an arithmetic exception divide by 0, and it's also telling me that it happened at main line 6. So main as in the class name, main as in the method name, and then line 6, which happens to be this line. So it tells me that I had a divide by zero error on this line. That's important that you understand that because you're going to have to be able to figure out where the error or the exception is coming from. Very often, when you're dealing with exceptions, because they don't happen every time you run the code, this certainly will happen every time you run the code because I hard coded the two numbers. But assuming that I read these in from a user, it's not going to happen every time. It's going to happen once every now and again. And a big part of debugging code is going to be asking the user what they were doing at the moment that they ran into the problem, because it's not going to be obvious as to how they got this error um, or this exception without knowing what it is that they did. So you're going to have to think through that and look through all of your code and then figure out where the exception's happening. All right. So what happened here was Java actually threw an exception, and that's what terminated the program. Because this caused an error, Java declared, okay, we're done. I don't know what's happening. An exception has happened. It's up to you to deal with this. This is a terrible user output. We don't ever want the user to see a crash like this. So really, I should have handled this possibility. So I'm going to change my code around just a little bit, and I'm going to make it more like the code in the slide. So we'll return let's do a double, and we're going to call it divide numbers. All right, so it takes in nothing, and I'm going to declare a scanner system.in, and I'm going to read in two numbers. So system.out.println, I'm going to ask them for number 1, right? And then I'm going to ask them for number 2, and then I'm going to read in those numbers. Int num1 equals myscan.nextInt, and I'm going to do the same thing for num2, and then I'm going to calculate my double answer equals num1 divided by num2. All right, so other than needing to import scanner, there we go. That should all be okay. Down in main, I'm just going to change it so that I'm calling divide numbers, and that's really all I have to do because I'm not passing it any answers here. I'm not doing anything with the answer, so I should do something. Double answer equals that, and answer. Great, so that prints out my answer. All right, so let's run it once. Let's make sure life is good. I'm missing a return statement. I need to return the answer. All right, let's run it again. Okay, looks like it's running. It asks me for number 1. I type in 10. It asks me for number 2. And it says 10 divided by 2 is 5.0. Okay, so life is good. Now let's cause the exception. 10 divided by 0. And it says in exception in thread main, divide by 0. All right, so how do we fix this? Well, this brings us to new code that you've never seen before, which are what's called a try-catch block. So a try-catch block works like this. You put the words try around the block of code that you think could potentially have the problem, and then you put a catch block to specify how to deal with each of the exceptions that could happen. And then you've got this finally block at the bottom, which is how you would deal with some stuff after the try catch. We'll talk about that in a minute. All right, so where am I likely to have a problem? Well, the first thing that jumps out is that I might have a problem on this line. There's actually a potential for problems on these lines as well, but we'll skip over that for just now and we'll deal with this one. So what I'm going to do is I'm going to say try, and then I'm going to move that block of code into the try. Then I'm going to say catch, and I'm going to say exception, not exception. And you give it a variable name, E, CEP. All right, let's see if we can type this again. Here we go. All right, so this gives me a variable called E, which is of type exception, and it's going to have information about the particulars of the exception that we just threw. So I'm just going to print out something silly here, like I had an error, but I dealt with it. Because that's really what's happening here. When I run this code now, cannot find symbol variable answer. Return answer. Oh, because I declared it inside the try block. Much like anything else, try blocks have scope. So, like an if statement, anything that you declare in there only exists within the enclosing curly braces. So, I need to declare answer before I get in there, and then I should be good. It's going to tell me answer may not be initialized, so I'll set it equal to 0 to start with. Okay, all right, so let's run this guy. And it says, give me number one. I say 10. It says, give me number two. I say 0. I hit enter. And it said, I had an error, but I dealt with it. Your answer is 0. Now, is the answer really 0? No, it's not, because 10 divided by 0 is actually an error. You're not allowed to do that. So it's weird that it's giving me an answer of 0, but that's because I initialized answer to 0 before I started. Whatever I initialized it to, that's what I would have gotten here, because answer never got set. So very specifically, what happened here? Well, it read in my number 0 for this second number, and it set num2 equal to 0. Then it said double answer equals 0. It executed that. That was fine. Then it went into the try block. When it was on this line, an exception was thrown. We know the exception was thrown because before I put the try block around it, the program crashed. So it throws an arithmetic exception of divide by 0 on this line. At that moment, execution stopped in the try block, which granted there was nothing below that anyway, but if there had been other lines, it stops and it immediately starts searching for a catch that catches the exception. And right here, I'm catching all exceptions. That's what this is. I'm catching exception, which, as we'll see in a minute, is the parent of all exceptions. So this will catch every exception that happened. And then it executes the code that's in here, and then it moves on as if nothing had happened. Returns answer, which at this point is 0 because that never actually got set up here. So that's the way that a try catch block works. Anything that's inside of the try, it will attempt to execute it, and if it works, life is good, it just does it. If it doesn't work, then it tries to figure out which exception to catch it with, which exception type catches the problem, and then it executes the code inside of the exception, which doesn't result in a crash. So I want you to realize that this program successfully finished. When it says program finished with exit code 0, weirdly 0 means success in most operating systems. So it's actually telling you life is good. It got all the way through the program and there was no issues. Obviously, there are issues because it dealt with them. But all right, so that's how this works. We have a try block. You have whatever code you need in there. There can be more than one line inside of it. And then you have a catch block where you specify which things you want to catch. Right now, we're catching exception, which is everything. And then you specify how you want to handle that. If in your code you wanted to be able to figure out what kind of exception you had, you can look at the E variable. It has something called get message, which is a string. So I'll just produce that string and I'll tell you what the error was in parentheses here by putting an X in here plus there, like that. Okay, so when I run it now, uh, what is happening? Okay, yes. Okay, give me number one, 10. Give me number two, 0. And it says I had an error, divide by 0. So you'll notice that text is not in my string. It's actually coming from here. I asked the exception what the error was, and it told me it's divide by 0. So that's where I was able to get that. So I can write if code in here that says if e.getMessage is equal to divide by 0, I could do one particular block of code to do something here, depending on what it is that I'm trying to do with that divide by 0. All right. So obviously this is a silly example. It's not really useful, but I just wanted to prove that that code runs because it was able to detect that that's a divide by 0 error. So you can certainly write as much code as you need in here. So if you're wondering, well, what would you actually do in this circumstance? You ask the user for two numbers and they gave you a 0. That's really not great. Well, this is a made up example. Most of the time, your exception handling is going to be about real world problems that actually do exist. And in that case, you're going to want to deal with that problem in some way in your code. So think about it this way: if you have a user that's respawning in a game and the place that they died is inside a wall somehow, then you're going to have to exception handle that. When you go to respawn, you're going to need to be not inside a wall. You're going to need to move a little bit left or a little bit right or whatever the case may be. Likewise, if you died because you stepped on a bomb of some form, probably would be good to get you not to start off on top of that bomb again, because otherwise you're just going to go around in circles. So what you're doing in the catch depends on the actual problem. All right. So this is the list of many of the exception types in Java. So at the very top, we have object. And remember, object is the parent of all objects. Below object, we have something called throwable. And in Java, all exceptions are throwable. So they're listed underneath throwable. And we can see down here, there's many different categories. So we have runtime exceptions, which then have children underneath them, which include arithmetic exception. That one is the one that we were seeing. But you also have IO exceptions, which also have their own set of stuff over there. We're going to deal with this block in the next section when we talk about file IO. But right now, we're just dealing with runtime exception. So you can see some of the examples here are a legal argument exception, index out of bounds exception, arithmetic number format exception, and so on and so forth. So let's talk about the number format exception. That one's going to be an interesting one here. So I mentioned in our code that we currently are dealing with, there are actually two problems in this code. We only really dealt with one of them. So even leaving all of this try catch in here, I'm going to cause the code to crash. So here we go. It asks for number one, and I'm going to type in enda. Well, the code crashed. Why? Because when it asked for number one, it did a myscan.next int. So it's expecting me to give you an int, but in actuality, I gave you a string. And so the exception that was thrown here is an input mismatch exception. And you can see that it happened on Java line 9 of main, which is right here. So this particular one is an input mismatch exception. I can have the same thing if I fix this by saying, okay, just always read in a string. So string x equals myscan.next line. That gives me a string no matter what. And then I would have to convert it. So I would say int num1 is equal to integer dot, what is it? Integer dot parse int x. Integer dot parse int, is that not what it is? Okay, I have forgotten. Convert a string to an int in Java. Integer.parseInt. I just misspelled it. That's all. I put a capital P instead of a lowercase p. Sorry, I change languages a lot and it's different in every language, so sometimes I forget the exact syntax. Okay, so now when I run it, it asks me for a number. It's already defined in method. Oh, because I already called that x. Okay, this is what happens when you call things x. I'll call it a. That's much better. Don't be like me, kids. All right. So now it runs and it asks me for a number, and I type in enda. When I type in enda, you can see here, now I'm getting a number format exception from line 10, which is here. So this is where it's trying to convert it. So the first one was an input format exception, and this is a number format exception. It's happening the same in both cases because I'm giving it a string and trying to convert it into a number, and it doesn't know how to convert enda, or in this case, nada, into a number. So this is another exception that we would have to deal with. So again, try, and then we would move all of this where we read in the numbers inside my try block, because all of these can produce errors as well. And then I would need a catch, exception, e, and I would probably tell them something along the lines of, you gave me not a number. Okay, probably should be phrased better, but you get the general idea. Okay, so now at least it won't crash. What's the problem here? Answer. Oh, these are only defined in my try block. So I need to say int num1 and num2 and not redeclare them inside the try block. Okay, now they will be defined outside. Okay, and they may not have been initialized. Yeah, that's totally true. Don't you hate it when the compiler is really smart? Okay, num1 equals 0, num2 equals 0. Now are you happy with me, Mr. Whiny Pants? All right, so 10 and 0. Yep, that does the divide by 0 issue. Let's run it again. And it says, you gave me not a number. And then it gives me a divide by 0 because it's not happy with that either. The problem is, when it read in enda for this string, it was happy with line 11. The issue happened on line 12 when it tried to convert enda into a number. And what I mentioned before, and I need to reiterate this, in a try catch block, once you hit an exception, which happened right here on line 12, it no longer executes the remaining code in the try. This never happened. And since I initialized num2 to 0, I then got a divide by 0, and you can see it never happened because it never asked me for num2. So this is not great error handling. I'm just showing you that it stops executing the moment that you get to an actual problem. So, how should you really deal with this problem? Well, you should probably have a method that actually returns the integer. Um, Public static int get number. And this is where you should actually have your try catch. And if you don't get what you expect out of it, so try ask for a number. Let's do our 2 lines here. All right. I need to declare num1, set it equal to 0. All right. So then I have my try. All right. I need my scanner. All that needs to be up here now. Okay. Now I need a catch. And what I'm going to do in my catch is I'm simply going to call myself if it's not good. Return get number. Okay. I'm going to let you digest that for just a moment. Did I just use recursion? Yes, I did. Um, what's happening here is if I get an exception, I just go ahead and call get number again. And get number it knows how to ask for a number, and it'll keep doing that until I don't get an exception. Whenever I don't get an exception, it's going to return the actual value because there's my return statement. So now life should be good down here in I need to change this to be more generic because I'm going to give me a number. I'm going to call it multiple times. So down here, I'm just going to call in main. Actually, this is all up here in another method. So much code. Not really. I'm just going to get rid of divide number because it's got a bucket of crazy in it at this point. Okay, there we go. So now I have a method called get number. So I'm going to say int num1 equals get number. And then I'm going to say int num2 equals get number. And then we're not going to divide them because, well, bad things can happen with other stuff. I'm just going to print out something. But I want to prove that this works. So here's my code. It asks for a number. I'm going to type in 7, and it asks for the other number. I'm going to type in 10, and it just ends because, again, I'm not doing anything with the two numbers. But now I'm going to run it, and I'm going to type in enda, and you can't really tell, but I'm going to keep typing in enda. And you can see that it's going to just keep asking me for a number over and over and over until I give it a number. Then it ends. So that's because of my catch that is calling the method over and over and over again. So this is a self-healing method. Basically, it asks for a number, and if I don't give it a number, it's going to keep asking me over and over again for a number. Probably would make sense to tell the user what's going on. That was not a number. Try again. Try to be polite with your error messages. Even though you sometimes want to tell the user that they're being dumb, you're not going to actually do that. There we go. So now it's a little clearer as to what's happening. And when I type in 7, it doesn't say that. And again, if I type in any string down here, it still gives me errors, and it'll keep doing that until I type in the second number. So that's a self-healing. I'm using a try-catch block to go around in circles. You might be thinking, couldn't I have done this with an if statement instead of using this try-catch? Sort of, but an if statement can't really be used to tell you whether this succeeded or not. It it can tell you whether what you got was a string, but there's no inherent way to deal with exceptions. This is why you have try catch. They deal with exceptions. So life is good here. All right. So these are the different kinds of exceptions. And the reason that I bring this up is because you can catch these individually. In all of the examples that I've been showing you so far, I've just been catching exception. Because, well, that's easy. That's kind of the parent of all exceptions. So every time I did a catch, I just did catch exception. But you can actually catch any of the things down below. So, for example, let's take out our try catch here and make it so that this actually crashes for a moment. So I'm just going to turn this off. and turn off the catch because it won't let me have the catch without a try. All right, so we're going to run this again, and we're going to type in enda. Great. Okay, so the type of exception that it threw was a number format exception. I'm going to grab that exact string, I'm going to copy it, and then I'm going to put my try catch back in again. All right, so I'm going to leave this catch exception down here. And this time I'm going to add another version of it, which I'm going to paste in what I had as soon as I remember how to paste. Is it not that? It's not that. Okay, I'm just going to type in number format exception E. Okay, so now I have two different catch blocks, which you might be wondering, wait, is that allowed? And the answer is yes, that is allowed. So you're allowed to catch a format exception and then separately catch an exception. It is giving me a warning because the code is the same in both cases. And it's like, well, then why are you doing this? It's redundant. But you can definitely have different code. And so now they're different. So let's say system.out.println. Um, this is not a string. Okay, those are at least slightly different. All right, so let me run it again. And all of it's going to work pretty much the same way. When I type in enda, it says this is not a string. So you can see this is actually the one that ran, not the one down below. As a matter of fact, for this particular type of error, this is the only one that will ever run because it's actually throwing a number format exception. It's not throwing an exception. Exception being the parent will catch everything. So when it's the only thing there, it catches the number format exception because that is a child of exception. But if there's a more specific one ahead of it, then it will catch it in that block. And the advantage of this is you can have different strings or different handling routines inside of each of these depending on the circumstance. So you don't have to have the same code. So that's why this hierarchy is useful. You can catch the particular exception that you want, and you can have as many catch blocks as you need. So the flow of an exception. When a problem occurs in a try block, the exception is thrown, it stops executing the remaining code in the try block and immediately starts looking for a matching catch. It finds the best matching catch, starting at the top, working its way down. And then, if it has done all of that, it then moves on to a finally block if there is one, and then moves on after the try catch block. If it doesn't have an error, then it does everything in the try block and it ignores all the catch blocks and then moves on to either the finally. So, rules on catch blocks. You must have one or more catch block immediately following a try. So if you have a try, you must have at least one catch. This is the bare minimum of what you have. But you can certainly have as many catches as you want. So it's absolutely valid to have 2 or 3 or 5 catches, although practically it's probably going to be 1 or 2 in most cases. Um, Only one block will ever execute. So even though you have many of them, it's going to pick the first one that matches. So the order matters. It starts at the top and it finds the first matching catch. So in my case, what was thrown was a number format exception. Therefore, it hit on the very first try. If what was thrown was an arithmetic exception, it would check that it doesn't match and it's not a child of this. So therefore, it would go on to the next thing. It would check that, and it does match that because arithmetic exceptions are a child of exception. So it would match that one and do it. So it begins at the top and does them in order from the top down of the catch blocks until it finds a matching catch block. So it also means that you have to put them in a particular order. You have to put all the children first and then put the parent at the end, because otherwise the parent would just catch everything. All right, so that is our catch block. So this is where you have two different catches, one for file not found exception and another for just exception. That's perfect. All right, so the next thing to talk about is the finally block, which I've kind of breezed over. I'm going to just slide back a few slides here. So after you have a try block, you can have as many catch blocks as you need. They just go in here one after another. And then after that, you get to have a finally block if you want one. The finally block will always execute regardless of whether the try area had an exception and went to the catches, or whether the try area didn't have an exception and the catches were all ignored. No matter what, After the try is done, it will do the finally block. Now, you might wonder, well, why is this here? It seems like this is kind of redundant. And to be honest with you, it kind of is a little bit redundant because it's going to move on to the code that's underneath the try catch block one way or the other. So it's the next block of code that's going to happen anyway. So putting it in a finally block, it's really just a way of denoting that, by the way, this finally is part of this try catch. Um, the best example I can give you doesn't make a whole lot of sense this week. It'll make more sense in the following section when we talk about file IO. But for most things in Java, if you open something, so if you open a file or if you open an internet socket or you open a database connection, you're also going to need to close that connection when you're done with it. And that will be something you would do in a finally block. You would try to open it in the try block, and then no matter what, you would close it in the finally block. So that's a circumstance where you'd use it. But if I'm being honest with you, for the purposes of this class, you need to know what a finally block is. You're probably never going to use it in this class. You'll see it in code that you look at, but it's probably not something you're going to write a whole lot of yourself. All right. So in the end, the full syntax is you can have one try, and then it must be followed by at least one catch, but there can be as many as you want. They have to be in order from the weakest to the strongest, meaning the child all the way through the parent, all the way up to exception. So from child to parent to parent to parent to all the way up to exception. You don't ever have to catch sorry, you don't always have to catch exception. I know all of the examples that we've shown catch exception. It's a common thing to just catch exception because it deals with anything, but you don't have to do that. And then, as I say, finally, if you need a finally block, it goes down at the end there. All right, so best practices. Don't place a try block around every statement that you might possibly throw an exception. Take a block of statements, put one try around that, and then have all the catches for that block. So, what I'm saying there is this is this what I wrote is actually about right. Like I caught the exception that you're likely going to get here, but in reality, my try block only has a couple of lines of code. Most of the time, your try block's going to have more than two or three lines of code. You're going to clump all the stuff together and then have a catch for all the different types of problems, like the number format exception, and then maybe the arithmetic exception, and then exception to catch all the different options there. The only time you'd really use separate try blocks is if you're trying to distinguish between multiple statements that can throw the same exception. So, for example, if you're trying to open a file and then you're trying to open another file, and both of those could have exceptions, you might want to have different error messages telling you which file it was that had the problem. And so, an example of that is if you're in a game and you're keeping track of the best score in the game or the high score, then you're probably going to keep that in a file, but you also may allow the user to give you other information from a file, like maybe the list of users and their passwords may be stored in a file or something. That's not a great idea, but maybe it is. So you could have a couple of different files that you're reading in, and you would want to be able to tell the user the problem was you were trying to read the best score, the high score file when you had an error. That's a case where you'd have two separate try blocks because you want two different errors. Okay, so that's try catch. It's a pretty simple thing. And that is the first part of exception handling, which is catching exceptions. Before I move on, I just want to explain that try catch is something that is used in pretty much all languages. Python had this capability. Certainly, Java has it. C Sharp has it. Most languages have the ability to do try catch. That's the most important part of this section. There are two more things that we're going to talk about, which are less prevalent. And the problem is, once we talk about the second one, everybody tries mixing the first thing with the second thing. The first thing, which is the try catch block, is the part that you need to really understand. The other parts you also need to understand, but you need to realize they're a separate thing. All right. So that brings us to part two, which is throwing exceptions. If you are in the middle of a program and you yourself want to declare that an exception has happened, you have the ability to throw an exception. Now, why would you ever need this? Java has built in things for some types of exceptions. It knows that you've done a divide by zero. It knows that you were trying to read in an integer and you got a string. It knows that you went past the end of an array with an array index out of bounds. Those are things that it inherently knows how to do. But in your code, you may have business logic things that you're checking that may have an error. And so, like an example is you're dealing in a checking account or a finance account of some form, and the user tries to do a withdrawal out of the account, but they don't have enough money. Well, that's a circumstance where Java doesn't know there's a problem there. Java can give you a negative balance. It's quite happy with that. Negative numbers exist. But you yourself know that's something that's not really supposed to happen. So that's a circumstance where you might throw an exception. And so at any point in your code, you can simply say throw new, and then you can specify the type of exception that you want to throw. Typically, if you're throwing an exception, you're just going to throw exception. But you certainly could throw a new file IO exception or any other input format number exception or whatever it is. All right, so if you're going to do a throw anywhere inside of a method, you have to put a throws on top of it. All right, so in this example that we have, I'm reading in two numbers, and in the end, double answer is equal to num1 divided by num2. And I'm going to make sure that my num1 and num2 are never 0. So the way that I'm going to do that is up in the method where I'm actually reading in the numbers, I'm going to just check if they gave me a 0. So right before I return num1, I'm going to say if num1 is equal to 0, then I'm going to throw new exception. You can't give me a 0. All right. Now, the moment that I do this, I have to do something extra in Java, which is up here in main, I have to say throws ROWS exception. I have to declare on the method header line that this method sometimes throws exception. Anything that you could possibly throw new of down here has to be listed up here in the throws. So you have to declare as part of the method that, by the way, it can throw exception. And furthermore, I'm no longer allowed to call it without having a try catch block. So I'm going to have to do a try catch down here. And oops, what have I done? All right, try to move those two lines in here. What I'm going to do is I'm going to add a catch of exception because that's the thing that's thrown. And I'm going to say, you gave me 0, which isn't allowed. Now, I'm going to go ahead and put that in here as well. And I'm going to declare double answer equals 0 before I go in. Okay, so I declare it, it's set inside of the try, and then I have my print statement down at the bottom. Okay, so I'm going to run this code, and what I'm going to do is I'm going to put in the semicolon that I forgot, and then I'm going to run it again. What I'm going to do is I'm going to run the code, and I'm going to, for the first number, I'm going to give it a 0. Now, what's going to happen here is we're up in get number, and it is read in a string that has the number 0 in it. It's going to convert that, and that's going to successfully convert. So that's not going to hit the exception here. But then in here, it's going to throw a new exception. So when I type that in, it says, that wasn't a number, try again. So this particular exception very weirdly got caught by the try that I'm already in the middle of. This try catches exception. And so since it caught exception, the error message that I got was error, that's not a number. So I'm going to change this to you entered a 0 because that's the only time exception will be thrown here. All right, so let's try this again. All right, and I'm going to give it a 0. Well, I didn't hit 0 apparently, so let's try it again. It says you entered a 0, give me a number. Okay, so this will keep asking me for numbers. So it didn't accept that. And if I type in enda, it says that's not a string, give me a number. So the first time that it accepted something was that 10. And I have the same things going on here. If I say 0, it says no. If I say enda, it says no. And then if I say 5, it says, okay, the answer is 2.0. So this is very robust code. It's checking both, did I actually give them a number? And it's also checking that the number that I gave them is not 0. Now, it's actually kind of crazy code because you can absolutely take 0 and divide it by a number, but this code won't allow you to do that. So if I say 0, 0 divide by 10, it doesn't work because it says the first number wasn't a number. So that's not great. But the point is that the exception handling is working. I will point out that in this exact example, because the throw is inside of a catch, I don't technically need this. I was wondering why it wasn't underlining it when I started to write it. Um, because this throw is being caught by this try, I actually can remove this, and I believe the code will still work, even without the try down here. So let's try this again. I think this is all just going to work. Yep, it does. Yep, and 2, and the answer is 5. So the reason for that is because this throw happens inside of a try. That try is the one that's going to catch it. So Java can throw an exception here if this is not an integer, and I'm throwing an exception here if it's a 0, and both of those are being handled by this try catch block, which robustly kicks you back and asks you to enter another number after giving you an error message. So this is great. If this was a throw that was not inside of the try catch, then let's throw exception hello. Now all of a sudden it's not happy with that, and that's simply because it's an unhandled exception. So now I have to say it throws exception, and now it'll accept that fact that this is an unhandled exception. But down in my main, every time I call get number, it says you have an unhandled exception called exception. So now all of this has to be back in a try catch block again. So the only exception that could have been thrown by the method is exception, and I know that they said hello, so I'm just being smart here and saying you said hello. Unreachable statement. Okay, Java's being very clever. So this is all correct code, and I absolutely can throw that exception, and I need the try catch down here. All of that is correct. But what Java has noticed is once this is here, you're never getting past this line because that always throws an exception, and that's going to stop execution in this method. So everything below that line is unreachable code. That's what it's saying. Line 9, which is right here, is unreachable code. So in order to fix that, I'm just going to move this down underneath the try catch, so it's the last line. Now it'll be okay with it. Okay, well, it realizes that's unreachable because either the try returns or either of the catches return, but no matter what, you're not getting here either. So, all right, Java's very clever. Um, the point still stands, which is that throw at any moment you can throw a new, and then you specify what type it is, and inside of the parentheses you can put a message. The message that you put in here you can get back out with e.getMessage down in your catch block, because e is the name of the variable. So I could have actually said you get plus e.getMessage, and that would actually give me the hello back out of the exception string from up here. All right, so here's another example. We have public static void do stuff, which throws exception, and the only line of code in there is to throw a new exception. So down in main, in order to call do stuff, yikes, you have to put that in a try catch block, and in the catch you must catch exception. So this is what's called a caught exception or a mandatory exception, because the fact that I'm throwing it or possibly throwing it means that it has to be caught. Java will not allow you to write the code. This is a design decision that is not consistent in C sharp. In C sharp, it allows you to throw an exception and not catch it. But in Java, once you throw an exception, you must catch it. Different design, different languages. All right, here's a compile time error, and that's simply because I didn't catch what could have been thrown here. Will not let you compile that code. All right, so here's a quick aside of the keyword final, finally, and finalize. All three of these exist in Java, and we just want to review real quick the differences. So finally is the new one that we're talking about here, and so let's deal with that one first. That's the last part of the exception handling underneath try and catch. So finally is the end of a try catch. Final is something that we looked at the very beginning of the class. It's how you declare a constant in Java. So if you're making a variable that cannot change, you say int, sorry, final int my number is equal to something. An example of where you would do that is if you were declaring pi. So you might say at the top of your code, something, I'll do it right up here in this method. You could say public um, double pi equals 3.14f to say it's a floating point number. So that would be fine, but I can put the word final on front of it, and now it can never be changed. If I later try to say pi equals 7, I get a compile error, and the error is can't assign a value to a final variable. So it's allowing you to create a variable that can never be changed. So that's final. So finally, try catch blocks. Final is a constant. And then the last one is finalize. We've not really talked about this, but inside of your classes, we know that you can make a constructor, and you do that by making a method which is called the same as the class itself. So if you're creating class dog, you make a method called dog, and that's your constructor. But there's also such a thing as a destructor, and that's done through a method called finalize. It allows you to clean up stuff in an object when the object is being destroyed. So when does an object get destroyed? Well, very specifically, if the garbage collector is about to collect it, it will call finalize, which allows the object to clean up after itself. It's not something you do very often, but it's useful to be aware that it exists. So final is constant, finally related to try catch blocks, finalize is a destructor. All right. So part 3, we've talked about how to catch with try catch blocks exceptions that could be thrown by Java. We've shown you how you can throw your own exceptions. And the last part is you can create your own exceptions. So you might have exceptions that aren't just arithmetic exceptions, input validation, range out of bound, index out of bounds errors. You may have an exception that has nothing to do with any of those things. So, for example, if you're building software in a car, you might need to know that the car didn't start. And so that would be a case where you might want your own exception for car not started exception, or car on fire exception, or whatever the problem may be. So Java allows you to declare your own exceptions. They're just classes that inherit from exception, and you have to give them a constructor. So I'm going to do file new Java class. I'm going to call it enda exception. You can call it whatever you want, of course. And I'm going to say it extends exception. All right. So in order to make this work, I have to do two things. I have to give it a default constructor, so public enda exception, and all it does is it calls super. Um, Actually, it doesn't have to do anything. Sorry, it's the overridden one. So public enda exception takes in a string message, and you're going to call super with message. Super is how you call your parents constructor, which is exception, and exception sets up the exception object. So if you have a particular string that you want to pass up, then that's how you do it. It comes in as a parameter to your constructor, and you simply pass it to your parents constructor, which is the exception constructor. Okay, so now I have an end exception, and instead of throwing new exception that I did down here, I can now throw new enda exception, and it will allow me to do that. Now, I still have the same problem that this is unreachable code and all the rest, but that's how you do it. You make a class, you give it a constructor and a default constructor, and an overridden constructor even, and that's it. You make it be a child of exception, and now you can call that as a exception. And so in this example, we have a class insufficient funds exception, back to my bank example. And so you have your default constructor that does nothing, and then you have your overloaded constructor that simply passes the message up to the parent. All right, so as a final topic here, there's such a thing in Java as an unchecked exception and a checked exception. So unchecked exceptions are things that can happen, for example, divide by zero, that there's no rule in Java that you have to catch divide by zero. You are welcome to write code that crashes every time it divides by zero, which is kind of bizarre. But there is a rule that if you ever throw an exception, then you must actually catch it. And that's checked by the compiler at compile time, because it's a checked exception. So most exceptions, anything that inherits from exception, are checked, and therefore you have to put the try catch block. Whereas things that are childs of errors or runtime exception, they are actually unchecked, and you don't have to put them in try catch blocks. Weird distinction. Honestly, there's a whole debate about this in communities about whether this made sense or not. As I say, when C Sharp came out, which is a derivative of Java, they didn't make this distinction. Everything in C Sharp is unchecked. There is no checked example. So that's checked versus unchecked. And then we have two final slides here where we're just going to ask you what kind of exception are we getting here. And so in this example, we have a block of code. And in our block of code, I have a lot of little windows. Let me move them all out of the way. In our block of code, we have a main method, and we have this data input stream, which we haven't really talked about yet, but that's something that you can make. And then it asks you to read in a character. It uses system.in.read, which you've probably never seen before. It tries to cast that to a character. And so the question is, what problem do you have here? Well, the problem that you have is you can have an IO exception from a data input string. So it's telling you here, line 9, which is where you attempted to do this read, you could have an error on that that is an IO exception. And since that's a caught exception, or a checked exception, sorry, that means it has to be checked and you didn't check it. So that needs a try catch block. Over here, we have another one, and this is a circumstance where you can get a divide by 0. Since this one is not checked, you don't have to put a try catch block around it, but it does mean that if you ever end up with x equal to 0, then, well, unfortunately, you're going to crash. Okay, so out of this section, there were a couple of things that you learned. You learned about try catch, which is the most important thing, that anytime you have an exception, whether it was thrown by Java or thrown by you need to have a try catch block around it. The try block will only execute up until the moment where it hits the exception, and then it'll jump out and do the catch. The catches are read from the top down. You'll have the most specific one first, and you'll work your way down to the most general one at the bottom, which is usually catch exception. You can have a finally block if you want to, although not very common. You can throw your own exceptions. That's simply done by throw new exception. And you can create your own exceptions, which you can then throw by creating a class that inherits from exception. So that's everything to know about exceptions and error handling in Java. And I will see you in the next lecture where we will talk about file IO. See you then.